Here's section 6.2, title, factoring trinomials of the form x squared plus bx plus c. So here's the first problem. It says factor each trinomial completely if that trinomial cannot be factored, say it is prime. Before we start working with problem number 1, I just want to remind you of a definition that you saw in section 6.1. It says to factor a polynomial means to write the polynomial as a product of two or more polynomials. In this case, it's just going to be two polynomials. So here we go. Let's get rid of that. And this, the way that we're going to be factoring this is using this method that I call the X method. And now you know why I call it the X method, because this looks like an X. And then I need to come up with these two numbers, 7 and 6. Where do they come up? I mean, where do I get these numbers? The number 7 comes from the middle number, or the B, and the 6 is represented by whatever the C is. In addition to that, above the 7 you have a symbol that is sum, and below the 6 is a symbol that is a multiplication. And this is how we're going to be using this diagram here. You basically need to come up with two numbers that when you add them you get 7, and then when you multiply them you get 6. And what two numbers satisfy these two conditions? 6 and 1. 6 plus 1 is 7, 6 times 1 is 6. So we're good. Once you have these two numbers, then this is what you're going to do. Remember, to factor this is expressing this as a product of two polynomials. So here are the two polynomials. You should be able to follow where the 6 and the 1 come from. Now, where do the x, this x, and this x, where do they come from? Well, again, if you remember the definition that I showed you at the beginning, is to express, to factor this is to express the polynomial as a product of two polynomials, in this case two binomials. That's why this is your answer. To bring the point home, notice that if I was to multiply this by a technique that you know as FOIL, it was presented to you on the previous chapter. The product of the first, the product of the outside, the inside, and the last, this is what you get. And notice that if you were to combine these two terms, you get 7x, and this trinomial, after you simplify, is the original trinomial, so it checks. So this is the answer to number 1. This is how you factor this trinomial using the process of the X method. And also, you always want to be checking your answer by FOIL. Let's go on to number 2. Same idea, different problem, x squared plus 12x plus 20. If we apply the X method, you should see where the 12 comes from and the 20. Now that we have that, we want to come up with two numbers that the sum is 12 and then the product of those two numbers is 20. What works? 2 and 10. 2 plus 10 is 12. 2 times 10 is 20. So then what do I write as my answer? Again, to factor this is to express it as a product of two polynomials. So this is what I get. X plus 2, x plus 10. And how do you know that this is the correct answer? You can check by FOIL. Again, first outside, inside, last. And this is what you get. If you were to combine these two, you end up with 12x. So this equals the original. So this is your answer. Let's move on to number 3. Same directions, same process. So I'm looking for the sum of two numbers that add up to -5, and then the product is equal to -24. What is that? -8 and 3. So now I am going to express this as a product of two polynomials. and is x minus 8 and x plus 3. You want to check by FOIL. So the product of the first is x squared. The product of the outside is these two, which is 3x, the product of the inside, and then the product of the last, which gives us this. And notice that if you were to add these two, you end up with negative 5x and hx. So again, this is your answer. Let's go on to the next one. This one, same directions, but notice that you have two variables now. In addition to the x, you also have a y. So it's very important that you keep that in mind. So if I was to work with the x method, notice that in front of the xy there's a 1. So that's why your b is 1. So what two numbers satisfy the sum and product of what you see here? And it is positive 7 and negative 6. Now, this is where you have to be careful. Since you have two variables, you might be tempted to write this as your answer, which is x plus 7, and then x minus 6, which is what we have been doing on the last examples. But notice if you were to FOIL, especially the last two terms, 7 times negative 6, you get negative 42, and you have negative 42y squared. So what do we need to incorporate into the polynomials so that you can end up with not only negative 42 but also y squared? And this is what you need to include. Right next to the x, right next to the 7 and the 6, you need a y. And again, just to double check that you have the right answer, use the process of FOIL to multiply, and notice that you're going to end up with this. If you were to combine these two middle terms, you end up with 1xy. So hx. This is our solution. This will be incorrect. 5, same as number 4. You have two variables, so keep that in mind. Use the process of the x method. Excuse me. And then two numbers that satisfy the sum of 5 and the product of negative 14 is the two numbers are negative 2 and 7. So what do we express as the we need to express this as a product of two polynomials. So it turns out to be the following. Just like on number 4, we need to include an n right next to the negative 2 and the 7. So you can end up with n squared as the last. So you can end up with negative 14n squared. So then from here, you will always want to check by using FOIL. Once you do that, this is what you get. And notice that this gives me 5mn. So this checks, and this is my answer. 6. This one's a little bit different, and you'll see why in just a second. So you use the x method. The sum is negative 1, the product is 6. You think of two numbers that satisfy that. You might be tempted to say negative 3 and positive 2, but if you add them, you get negative 1, but if you multiply them, you get you get negative 6. So it doesn't, these two numbers do not satisfy the sum of negative 1 and the product of 6. So what are the two numbers that satisfy that? So in this case, it is not possible. So that's why the answer to number 6, and if you read the directions, it says if the trinomial cannot be factored, say it is prime. So the answer to number 6 is prime. Let's go to number 7. Here we go. This is going to change a little bit. Follow along the directions. It says factor each trinomial completely by factoring out the GCF first and then factoring the resulting trinomial. And you did this on earlier section 6.1. So you look at this trinomial, there's a common factor of 5. Notice that the coefficient, the leading coefficient is not 1, it's actually 5. So this is another hint that you need to pull something out. So you notice that the GCF is 5, you take it out, and this is what you get. You multiply it back in, you get the original trinomial. Now, why do we do this? Because this looks like this looks like x squared plus bx plus c, what you saw at the beginning of this video. So now, at this point, we're going to apply the x method with what you see inside the parentheses. So you have 6 and 8, the sum, the product. What two numbers satisfy that? 2 and 4. So then you express this in factor form, product of two polynomials. So you have x plus 2 and then x plus 4, and then bring down the 5. It's very important that you bring down the 5. You check 5 FOIL, bring down the 5, multiply these two using FOIL, and notice that this gives me 6x, and it checks. You can multiply the 5 in, and after you simplify these two, and it should equal the original, or you can just simplify this, and it should match what you see here inside this first expression that we wrote. Let's move on to number 7. Excuse me, number 8. So here we go. Same idea as number 7, but notice that in this case is a little bit different. This is not in standard form. So then all we need to do is just put it in standard form, and this is what we have. You look at this trinomial and you want to pull out the GCF, which turns out to be x. Once you do that, this is what you get. You get x times this trinomial, and then at this point you apply the x method, and you have 10 and negative 75. What two numbers satisfy those two conditions, the sum of 10 and the product of negative 75? 15 and negative 5. So then this is what we have, and at this point you check, and notice that all I'm going to do is I'm just going to FOIL this. The product of these two binomials, it should match that. Once you do that, after you simplify, notice that you get 10x. So this is your answer that you see here. This is your answer. And let's move on to number 9. So here's number 9. It says factor each polynomial completely. If the polynomial cannot be factored, say it is prime. If you look at number 9, it's already in standard form. And notice that the leading coefficient is not 1. We have a negative 3. So we need to make sure that we catch that, because that means that there's a common factor that we need to pull out. If you look at this trinomial, the GCF is actually negative 3r. So if you pull it out of each of those three terms, you end up with the following expression. And then at this point you apply the x method. So we're working with negative 2 and 1. What two numbers satisfy the product and the sum and the product of those, what you see there? Negative 1 and negative 1. So then your answer is going to be negative 3r times r minus 1 times r minus 1. Or you can express this as negative 3 times r minus 1 squared. And at this point you should feel comfortable checking your answer. Here's 10. If you look carefully, this is not in standard form, so you put it in standard form first. Again, the leading coefficient is not 1, and not only that, is a negative. So you want to pull out a negative, and also the GCF out of those three terms in the polynomial, in the trinomial, which turns out to be negative z. You pull it out, you factor it out, and then you end up with that trinomial inside the parentheses. At this point you use the x method, and you're looking for two numbers that satisfy those two conditions. Sum and product is 4 and negative 3. This is your answer, and you can take the time to multiply these two binomials, and they should equal what you see here. So but this is your final answer. And this concludes the video.